Hello, we are here to talk about predictable user experiences and how to achieve that. And to do so, we have to talk about predictable code and how to achieve that. And the concepts we are going to go into related to that is the concepts of explicitness and constraints. And these are very abstract concepts and they transcend any programming language. But they are important to achieve a predictable user experience. And we're not going to make this a very abstract and theoretical introduction. We're going to be very practical about this, but it's important to keep in mind that explicitness and constraints in your code makes your code more predictable, which at the end makes the user experience more predictable. But enough abstractions and theory. Let's talk about something very practical, which is the fundamental React example, the counter. And this counter can, of course, increment and it can decrement. But if we take a look at how we express this in the code, we see that we have this useState, which has a state of type number, and it starts with the initial value of 0. We can consume this count and we can set this count. And just to interrupt a moment here, I know that this fundamental example is so fundamental that these concepts we're going to talk about seems unreasonable to put on top of this simple example. But we have to start somewhere. And I think this fundamental example helps us to understand better the principles, and then we can apply those on more complex examples as we move down. So anyways, we have our counter here, and where we start being explicit about how this count actually works is in the implementation of the UI. So on the click, we actually change the count from the current and we decrement by 1. And on the increment button, we use the current value and we increment by 1. Now the thing is that looking at this state itself, we don't see that explicitness and there's no constraints to how it can change. Like we can use this set count and do whatever we want. So for the next developer looking at this state, they wouldn't understand how it can actually change. And what we're going to do now is that we're actually going to apply more explicitness and constraints to this state value. And the way we would do that, first of all, is to type some actions. So either we can decrement this count or we can increment this count. And instead of using useState, we're going to use a reducer. And this is actually the reason why you use a reducer. It's because you want to apply some more explicitness and constraints to that state. So let me show you what I mean. Let's put the action in here. And what we're going to do is that we're going to switch on the action type. And we are going to say when we decrement, we use the state, we return the current state -1. And when we increment, we return the current state +1, or we'll just return the state. Yes, and then we of course need to give it the initial value. So what we've done now is, let's just finish this. Let's say we dispatch type, this is decrement, and here we would dispatch a type of increment. Now, of course, the example works exactly the same, but what's happened now is that, first of all, we are way more explicit about how this value can change. We have typed a decrement and increment, and in the implementation of this reducer, we have created constraints so that the only way this value can change is by decrementing or incrementing. So this is at the core of what we're going to talk about here. It's chasing this explicitness and the constraints to create a more predictable user experience. Now let us talk about making implicit states explicit. Now this sounds theoretical and abstract again, but we are going to be very practical about this. So our last example with the counter had no implicit state. Like the state was a number. There's nothing hidden there. But if we look at more traditional state, like real life scenarios, it might look something like this. This is a async flow where we do some data fetching. Now you might say that this is explicit, since we have an indication if it's loading or not. We have the data, and we have an error which is there if it's a string, or it's null if the error is not there. And yeah, that's quite explicit. But let me ask you this. When is this state loading? And you probably say, well, it's when isLoading is true. And then I can ask the question, what if isLoading is true and error is a string? Are we loading, or do we have an error? And the point here is that we can't really answer this question. It's up to the consumer, the UI implementation, to decide what to show to the user. And that's not ideal. Like, we should be so explicit with this state model that there's no chance of getting that thing wrong as a consumer of this state. And that's what we mean about implicit states. Those actually lead to unpredictable user experiences. So what we're going to do now is that we're going to actually make this explicit. And the way we're going to do that is by simply introducing a new property. And we are actually going to call that state. And then we're going to talk about what are the actual implicit states hidden within this state model. So the first implicit state is that the data isn't loaded at all. Like, we haven't even started fetching the data. So we are going to name that state very explicitly. It's a state of not loaded. And in this state, we decide now that we don't have any data, and of course we don't have any error. So we're going to leave it as is. But then we're going to move to the next state. And the next state we're going to call loading. But here we don't really have any data either, and we certainly don't have an error. So we're going to leave it as is. And then we're going to create a loaded state. And in the loaded state, that is when we actually have the data. And finally, we are going to have a state of error. And when we have an error, we actually have an error that is a string. So what we've done now is that we made these implicit states completely explicit. And we are back with our explicit state, and we are going to take a look at, with this explicit state, how do we actually change it? Now, what I've done is that I've also introduced actions related to this asynchronous flow, where we have an action to start fetching the data. Also, we need an action for the success of fetching that data, or there might be an action related to an error fetching that data. Now, the way you would typically implement this reducer is that you would switch on the action type, where you would, on fetch, you would return the state of loading. When it's a fetch success, you would return the state of loaded with the data. And if you have an error, you would return the state of error with that error. So, how does this asynchronous flow run? So currently, when we click this button, I can do that now, you see that it changes loading, and then it's loaded with that data. And the way this flow works is that it calls this callback of fetch, which dispatches fetch to the reducer to change it to the loading state. Then it starts a side effect of doing the fetch, where we dispatch a fetch success with the data when it's done, or an error if it fails. Now, the thing is that this is not necessarily how it needs to work now that we have explicit states. And what we're going to point out is an actual problem with doing it this way. So if I were to click fetch multiple times here, you see that it constantly, it doesn't matter. It just moves to loading, or it moves to loaded, it basically, the reducer is at the mercy of my clicks, right? We are dispatching to the reducer, and the reducer will always move into whatever state based on the action coming in. Now, this doesn't create constraints enough. Like, it creates constraints in the sense that these are the only actions that can change, and these are the only states we can move into, but we can add even more constraints on this. So what we're going to do now is that we're going to use a function from React states, which is called transition. And with transition, we're going to pass the state and the action, and we are going to describe these explicit states. So not loaded. What actions should we allow when we are not loaded? Well, we should allow you to fetch. And when you fetch, we want to move into a loading state. And when we are loading, we want to deal with fetch success. Let's see. The state is loaded, where we get the data on the actions. Let's insert that. And we also deal with any errors. So let's do the same here. We have an error state, and we'll move into the error state with that error. And we have loaded and we have errors. So we're currently not doing anything. If the data is loaded, we don't allow you to do anything more. And if there's an error, we don't do that either. Like, that could change, but this is how we set it up for now. So what did we actually do now? Well, since we have these explicit states, we can actually decide what actions do we want to deal with in the certain states. What actions are valid within each state. So in this case, the only action that is valid when we are not loaded is to start the fetching. And when we do the fetch, it moves straight to loading. And while we're loading, that is when the success and error actions are valid, which either moves us to the loaded state or to the error state. Now, what happens when I click the fetch now is that I can click as much as I want, but it only loads it once, because that is how I modeled it. I created those constraints within the reducer. So the consumer of the dispatch, they don't decide anymore how this state should move forward. It's the reducer that decides this. So we added constraints to create more predictability. But we have another thing here that's not ideal, and that is, even though I have constrained these state transitions, when I click this fetch, we are still dispatching. And more importantly, we are still doing the fetch. But maybe we could change this. Maybe since we have these explicit states, that we can kind of turn this around. So instead of having this fetch callback, what if we would rather use an effect? So when do we actually want to fetch this data? Well, it's when the reducer is in a loading state. So by using one of the utilities from React states, we can say that when we are loading, that is when we want to go and fetch this data. So now we are going to dispatch instead the fetch to the reducer. And again, it has the same constraints, but as I click fetch now, no side effects happen, because the only way we can run this side effect is if the reducer actually moves into a loading state where that side effect should happen. So we've been able to create even more constraints now, which makes things even more predictable. Now let's talk about how you would consume this explicit state. And we are back with our state definition with our explicit states. We have the actions, we have our reducer transitioning valid actions to explicit states. And we have our used state effect, which runs the side effect when the reducer deems it okay to move into the loading state. Now, one thing that you would typically do is that you have a combination of the reducer and you're running some side effects related to that. So a natural thing to do is to move this into a hook. So basically you would just do this, and instead of doing state and dispatch here, you would express this as data, for example, where we say this is data, and then we return that data. So now in the UI implementation, we would rather use that hook. So this is a good way to isolate logic, is to use hooks. And then if this reducer was to be used at a nested level in your components, you would just expose this data reducer on a context, and any piece of UI, they can just use the dispatcher to run any kind of logic. You don't have to create callbacks to do anything, because we want all the actions to go through the reducer. The reducer changes its state, and then there are certain side effects related to valid state transitions. Now, let's talk a bit more about how you would actually consume the state itself. So without explicit states, so you have this state model of an asynchronous data fetching flow, you would have to start looking at properties. You would typically use if statements or ternary expressions to figure out what to render. And it's all an interpretation by you. You have to figure out what are the different states I need to express from this state model. Now, with explicit states, we can actually take advantage of knowing all those states and knowing all these states as being explicit. So instead of showing the button here, we are going to use a utility called match. And this match utility knows about all these explicit states, so that when we are not loaded, we can show the button. When we are loading, we can show a loading indication. When we are loaded, we will have the data there, so we can show that. And then if we have an error, we can just say, oops. Now when I run this, we can see we're loading, and then we have the data. Now, the thing about the matcher is that it's not only used to produce like render UI. You can use it to produce different properties for a specific component or an element. Maybe you want to produce different kinds of styling based on the state. But what you know here is that it always covers all the states, right? And that's important, because when you have to interpret the state model and find these implicit states, you're in risk of losing certain states or missing out on certain states. So there are more ways to take advantage of explicit states in terms of matching and expressing UI. But this gives you an idea of the capabilities we have gained with these explicit states. So as a summary here, we have actually learned a new way to think about reducers. Because in traditional applications, and the way we learned about reducers in React in the first place, is that you have your UI, and that UI calls callbacks. And these callbacks, they might dispatch something to the reducer while starting some asynchronous side effect, which might continue dispatching to the reducer. And whatever action the reducer receives, it will change its state, which will affect the UI. So you can think of this as the reducer being at the mercy of all the actions coming in. The actions are commanding the reducer what to do. It doesn't really have a say in this. What we have done through this introduction is that we turn it around. We have made the reducer the primary engine of the user experience. So the UI can ask, like dispatch an action and ask the reducer, is this valid now? And the reducer decides to act on that action if it's in a valid state. And if it makes that transition, that can trigger a side effect that runs some asynchronous logic maybe, and in turn dispatches an action, which again asks the reducer, is this a valid action now? Which might transition the reducer into a new state, which then goes back to the UI, and that's the story. And this fundamental change is exactly what creates more predictability in your application. Now, it's really important that you don't need to have these explicit states for everything. Like use state is perfect in some situations, use reducer is perfect in other scenarios, for example with the count. But you will find yourself very quickly getting into situations where you model state and they start to become or they start having implicit states. And you can find those implicit states quite easily by you defining a value to be optional, or it's there or it's null. This implies that there is some implicit state going on, and you would benefit from being more explicit. So I hope this was a good introduction. There is more to learn about React states, on how to express state. There are different patterns you can use. But at the end of the day, I hope this helped you gain some perspective on how you can express state and how you actually enforce explicitness and constraints in your code. Thanks for listening.